Welcome to solverfy.
We're asked to show that the complete graph K5 is nonplanar, using an argument similar to the one given in example 3. So, consider the first three vertices of K5. Now we know that these must all be joined since the graph is complete. So it follows that V1, V2, and V3 form a triangle. Fourth vertex, V4, is either inside or outside the triangle. So, let's suppose that V4 is inside the triangle. Well, they must be joined to each of V1, V2, and V3. And then the triangle is divided into 4 subregions with these new edges. But the fifth vertex must go into one of these regions. No matter what region is chosen, however, V5 is not connected to at least one of the other vertices. I'm sorry. So the triangle is actually divided into 3 subregions, going to one of these regions. I should say there's 4 regions. We're including the outside as well. But again, if we're outside the triangle, we still have the issue where V5 can't reach V4. If we're inside the triangle, then V5 is not going to be able to reach one of V3, V2, or V3. So that's not going to work. So now, let's suppose that V4 is outside the triangle. And again, we know that V4 must be joined to each of V1, V2, and V3. which forms 4 regions again. And of course, we have that V5 must be in one of these regions. But it doesn't matter what region we choose, V5 cannot join to one of the other vertices if it cannot cross edges. So for example, if V5 is not in one of the 3 newly created regions outside of the triangle, then it follows that there's going to be one vertex it can't reach. If it's inside the triangle, it clearly can't reach before. If it's in one of the newly formed 3 regions, it's outside the triangle. And we see that there's going to be exactly one vertex that it can't reach. And therefore, it follows that we have a contradiction. And so it follows that K5 is not planar.